Okay, welcome to Team 3's presentation for the Project 3. My name is Raven Ray. I am the team captain.
I'm Cole Trammell.
I'm Mallory Raska.
Testatori.
Can you say that again, Jeff?
I'm Jeffrey Testatori.
Okay.
I'm Shreya Sharangat.
Okay, so first off is a UML use case diagrams by Mallory.
So, of course, this is the basic instructions and walkthrough of the game. Of the players of the game, there are two types. The user is one, and then all the other players are controlled by the computer. The user can follow two basic paths. One, they're the only ones who can start the game, and then both the user and the computer will take turns as the game continues, including rolling the dice, and when the dice are applied, depending on what dice are rolled, they can choose how to implement that. But yeah. And then here are the specification tables for the use case diagram. It lists the triggers and conditions of what causes the choices to be made, and of course the flow of how the program interprets what's being chosen and how it flows. Here we have the UML class diagrams. So these are all the classes and their the associations. Of course, there are dependencies with some classes, and inheritance and aggregation. The aggregation is between the role and character classes to the player, because, of course, a player cannot play the game without a role and a character. Otherwise, nothing would happen. And the comp and user are inheriting from the player class, and the comp brain class is an interface working with the comp. And then these are all the the diagrams from the previous page, just blown up larger to be able to see more.
For the classes developed, we all split up and created different classes and different aspects of it. Cole split and did the dices, including each individual dice and how to roll it. The player class, which includes both the user and the computer players, are created by Jeffrey. The character class, the Project 3 and the GUI were all created by Shreyash. Mallory created the roles for the players, and Shreyash created Node and the doubly linked list. On the screen is a list of all the classes for Project 3. Their creators are listed first, and collaborators are listed afterwards. In this model of the game class is the top class of all of it. It uses all of the other classes depicted. So when you first call game, it creates players, which it then calls the player class. Then it creates one user, and depending on how many other players you will have, it will create that many computers. And after it creates each player, the game will then give each player a character. It will call the character class, get a name, and assign that name with attribute and give it to that specific player. And after that, it will call the master role class, which will then give a role to the player and how will they win. And after the setup is finished, the game will finally call the roll dice class to roll the dice for that turn, and will keep going until someone wins. For the view is going to be Shreyash.
So for the view, I decided to modularize most of the components of the view. This would promote reusability of code, which is a huge part of object-oriented programming. I also implemented a lot of object-oriented concepts and designs within the GUI. For instance, inheritance, generics, interfaces were implemented in the different components within the view. Also made several user-defined UI elements such as combo boxes, dialog boxes, pop-ups throughout this game. I think all of this helps make the game more responsive and more user-driven. So the controller was integrated within the view. Did this because JavaFX is a single-threaded application. When we tried to make controller, it was difficult for us to access a different thread from the controller. That's why we decided to use the view to better integrate the game with the game class. In doing so, we also found out that this reduces a lot of lag and increases the responsiveness of the GUI with the game class. So for the GUI, I implemented the GUI using JavaFX. You can see this is a screenshot of the GUI when it's working. As you can see, all the black boxes represent players who are playing the game at that instant. You can see your role, your character, bullets, your arrows throughout the game, and then you can also see your dice roll. Um, I made a modular design to again promote reusability of code. All the elements that you see here are modular, and use object-oriented concepts.
For the pop-ups, the first pop-up that you get when you're running the game is how many players are going to be in the game. This is going to include you as the user. So we have it for 4 to 8. And after you select how many players you want to play in the game, it asks if you want to use extensions or not. And if you choose yes, it includes all the extensions. And if you choose no, it's just going to be the base game. After the extensions pop up, it will then show the board on the top right. It doesn't show any dice, and it sets every player to a character. You can see who's who, how much life they have, and after players start rolling, it will start to display dice on the screen. During the game, there's some pop-ups that can occur. For example, whenever you roll 3 dynamites and you have to end your turn, a pop-up will show saying dynamite. And whenever it's a user's turn to roll, the pop-up will say your turn to indicate their turn. Whenever it's a computer's turn, a pop-up will show to display the player's character name's turn. And if it's a user's turn and they have an activated ability, it will pop up. Do you want to use your ability? And the user can choose if they want to or not. For extending and implementing, it's going to be chat.
For extending and implementing, the comp and user both extend the player class because they both use attributes and methods from the player class. However, because comp and user are slightly different, they do need to be separate classes. The comp extends the player class so that I can use all of its attributes, including the protected attributes, which are necessary for the function of the comp class. The comp also implements the comp brain interface, as the comp brain interface provides templates for the methods that comp has to use to process what it needs to do for its moves and take the best course of action. For the interfaces, we have 2 in our program. The first is the component interface, which is used for the GUI, and the second is the comp brain interface. And we use these to provide templates to their respective classes that implement them. For example, in the comp brain interface, the comp will always have to use the methods to determine its ally, find its target that's X number of spaces away, and find the best target given its options. And for inheritance, Oh, for inheritance, it'll be
Um, so I inherited a bunch of properties from confirm dialog box into ability dialog box, attack dialog box, and drop down dialog box. I did this because most of these dialog boxes had similar properties. The only thing that was lacking was extending the functionality. For instance, an attack dialog box just has um, attack left or attack right button instead of a yes or no button. And the functionality of an attack left or attack right is different from yes or no button. So that's why I decided to use inheritance, the confirm dialog box mod. I also implemented generics within the project. This was to ensure that layout constraints are in check within the GUI. As you know, you cannot store a horizontal box within a vertical box. So this just ensures that you get the type of data that you put into the generic class declaration. I use this within the token class because it's been used a lot of different times within the GUI. For instance, it is used for life points and arrows and even the character descriptions. Now for integration testing, it'll be Raven.
For integration testing, the two main classes that have this principle is the game and the board class. The game class brings in all the aspects of roll dice, players, characters, role, all together, and it runs it, and it gets the information, runs it, and analyzes it thoroughly to update the game on has how much life, how many arrows, is there an ability to be run at that time, etc., etc. For the board implements all of the three aspects, like the displays, the buttons, the drop-down boxes. All of it are in the board class, and so the board class will run everything all at once and display it. Unit testing is.
So the way that we decided to do unit testing is by creating a sample test case in each of the main methods on all of our classes. So an example of this is in the roll dice class. We start off by creating our object using the constructor and then manipulating our information using the methods. And then outputting that information to make sure that we are getting the correct outputs based on our inputs. So all of the classes, when they use unit testing, follow this format.